Here's some supplemental information on section 6.5, thermodynamics. Okay, so first we start off with some system. What we're saying is we have a system that has energy coming in and energy leaving, and it has a net change in energy, right? So if the amount of energy coming in, if it's coming in quicker than it's leaving, then what you're going to find is that you have a net gain, a positive gain of energy. So we just can rewrite this equation like this. So we can say the change in energy is whatever's coming in minus whatever's going out. Okay. Okay. So if we take this a step further, we can break this down into different types of energy. We could have heat energy. We could have work. So energy being added to the system is work. And we could also have energy being carried by mass that might be entering or leaving the system. Okay, so some kind of flow rate. Maybe you have some mass adding it with kinetic energy associated with, or internal energy or thermal energy or something. So this is the other component. Um, what we're going to look at when we look at so-called closed systems, this part comes out to be zero. Okay. We could also write it in this form. We could say change in energy is, whatever kind of change in potential energy, any kind of change in kinetic energy associated with the object or um, components of the object, and the internal energy, okay, of it. All right. So we'll go a little step further as we design, if we not design, but define thermodynamic systems. One of the things we'll say when we look at these, if we're talking about like heat or work done to a fluid, let's say, inside of a closed system or inside of a system, we'd say that there's no real potential energy associated with that system. If it's stationary, we call this a stationary system, so it's not moving. We have no potential energy, no kinetic energy associated with it. Okay, um, so these two would be zero. So then what you're left with is just delta E equals delta U. Okay. So what I said, delta E equals delta U. So for closed systems, I forgot the D. The like I said, the mass energy contained within the mass is zero. So there's no mass essentially coming in or leaving the system. Okay. So with that in mind, we can rewrite the equation like this. We could say the change in internal energy is just whatever change in heat in heat minus heat out, work in minus work out. So this is our change in our internal energy. Okay. And one of the other ways we're going to write this is that we can also write this in terms of rates. And usually this is more useful. So we could say the rate at which energy comes in minus the rate at which energy leaves is equal to just basically the change in internal energy divided by the change in time, right? So energy per unit time change. All right, so this is also power. So we'll see this in units of watts typically. Okay, there are other units that we could do like BTU hours, but we'll look at usually we'll look at watts. Okay, so that's it. This should be also called power. Forgot the R here. Wrote it down too quick. So that's good for this.